Hi everybody, it's Mrs. Frame, and we're going to do a couple of problems from your review sheet just to make sure that you guys are ready for this test. The first question I chose was number 5 on your review sheet. So let's get started. The question was, is it always, sometimes, or never? If a median of a triangle is also an altitude, is it an angle bisector, and how do you know? How do we know? Well, let's go. If it's a median, it cuts the base here in half, or this side in half that it's drawn to. If it's an altitude, it creates right angles also. So what we're trying to do is figure out, are these two congruent? Well, so far we've got side angle and side angle. And if we look here at this guy right here, reflexive property, we can say these two triangles are congruent through side angle side. So through CPCTC, these angles are congruent. So this is one new theorem that you're going to learn. If an altitude is also a bisector, an altitude is also a median, it is an angle bisector always. Moving on. Next question I want to talk about is number 10. So in number 10, you were asked to take all of these angles and look at this triangle and list the three sides in order from shortest to longest. Well, the rule about triangles is that the smallest angle will be opposite the smallest side, etc., etc. So if A is the largest angle, then CB is the longest side. If B is the middle angle, then the side opposite will be the middle length, and C is the smallest, so opposite that will be the shortest length. So from shortest to longest, we'd have AB, AC, and CB. Pretty simple. Moving on, we have this original problem, and I believe this one was question number 12. Yes, number 12. Here was your original, and you were asked two questions. First, you were asked to reflect across the x-axis and write the coordinates of S prime. Well, if I were to flip it, S prime would be over here, so it would be at -3 up 5. I know it's upside down, but you guys can manage it. So there we have the reflection at -3, 5. And then also was asked to rotate it about clockwise about the origin, which means that this point wouldn't move, it would just flip around. And so you'll notice it's down here. This is -3, -5. So there's a visual of that. And when you need help, all you got to do is flip your paper around or turn it or whatever. You can make it happen. You can figure it out. Okay, moving on. Let's go. All right. Here we have this question, and I know there were a couple of people that really were struggling with this one. So let's take a look. We're given this information that AD is an altitude to BC, which means that we have these two right angles here at the bottom. Also, we have AD as the median to BC, which means that AD cuts BC into congruent segs. So we know side angle side, these are congruent triangles. Okay, since they are congruent triangles, we know through CPCTC that these two angles are congruent. Okay, and so we can say that angle ABD, let me pause for a second. Sorry about that, guys. I needed a fatter pen. Alright, so for angle ABD is going to be congruent to angle ACD. So we can take our two quantities, y squared is equal to 4x minus 55. We get those doubles, and we've got a y squared, so we're going to have to think about what we're going to do with that. Also, we have these two congruent segments, so we can say that BD is congruent to CD, and that was the median. We could also, that was the median rule that helped us with that. So we know that x plus 2y is equal to 40. Well, it should go this way, but anyway, you've got that. So we have to decide now what we want to do. I think an easy thing would would be to do is take this 2y, move it over here, solve for x, and then substitute. So if we move the 2y over, we get x is equal to 40 minus 2y. And we can substitute that in right here, and we can solve this quadratic. So 40 minus 2y. And do a little work here. So we get y squared equals 160 minus 8y minus 55. Combining like terms, we get y squared equals negative 8y plus 105. And then let's put it in quadratic form by moving everything to the left. So we get y squared plus 8y minus 105 equals 0. And we're going to go ahead and factor that out. Thinking the factors of 105, negative 105 that are 8 apart are 15 and 7, negative 15 and 7. So that's going to factor y plus 15, and y minus 7 is equal to 0. And that's going to give us what we want here. Setting them both equal to 0 and solving, we get y equals negative 15 or y equals 7. Well, if we come up here right here, we have to find the measure of ABE. Well, if y is negative 15 and we plug that in, negative 15 squared is 225. That's impossible. This is not a 225-degree angle, so we have to throw that answer out. I think we're going to have to go with a y is 7, which would make this a 49-degree angle. And since they're supplementary, that one would make this 131. Now, back to what else we have to figure out. We know that y is equal to 7 now, and this is 131. We just have to find x, so we can go in here and plug it into this equation. X plus 2 times 7 is 40, so x plus 14. So x equals 26. And there you have that problem solved. Alright, here we go. Next one are the proofs. I did the proofs, all 4 of them, real quick. And so we're just going to move through them as fast as we can. AB congruent to AD. I'm sorry, not congruent, perpendicular. We're going to get a right angle there. And DC perpendicular to AD. We've got another right angle there. Now we have AB congruent to CD. So far we've got side and angle. And we have E is the midpoint of AD, which is going to give us these two congruent segments. Now we're supposed to prove that angle EBC, is congruent to ECB. So we want to prove that these two are congruent. So I'm thinking from these two congruent triangles, probably going to need to say through CPCTC that these two sides are congruent to give me these base angles congruent isosceles triangle. So I would start with my givens there, and I'm just going to zoom through them real quick. So I'm going to press pause and just have them zoomed. Okay, sorry about that. I just didn't want you to listen to me writing all of that down. Oops, I hadn't finished writing it down. Alright, so there we go. So we've got, first of all, we've got a side here that we had to mention. Now, the next thing we're going to talk about is coming off of our first givens, that we've got right angles. So we're going to say angle A is a right angle, and angle D is a right angle. Perpendicular segs form right angles. Moving on. We are now going to have to state, of course, that they are congruent. So angle A congruent to angle D. Right angles congruent. After that, that gives us an angle. So we're up to side, and angle. Continuing on. The next thing we have is E was the midpoint. So we're going to work off of this statement here. We're going to state that AE, seg AE is congruent to segment DE, because if point is midpoint of seg, divides seg into two congruent segs. Alright, then moving on, that gives us our last side. So we now have side, angle, side. We can say that the triangles are congruent. So triangle BAE congruent to triangle CDE through side, angle, side, step 1, 3, and 4. And moving on to 6, remember that I had talked about us using these two as our CPCTC. So BE congruent to CE through CPCTC. And lastly, we can now state that angle EBC is congruent to angle ECB, because if legs, then base angles. Yay. Alright, moving on. The next one you have here is circle O. We're trying to prove that AB is congruent to EF. We've got circles, we've got a radii or two, we don't have any triangles. So we have that BC is congruent to FD. We have that AB and EF are perpendicular to CD, which means we're getting some right angles. If we wanted to, we could draw in two radii right here. Knowing radii are congruent, I believe we could get to HL postulate. We've also got CO and DO as congruent radii. So if we subtract CB from CO and FD from DO, we can state that BO is congruent to FO. And then that way I could state that through HL postulate these two triangles were congruent, which then in turn would let me say through CPCTC that AB was EF. So again, I'll get the givens down and then I'll be back. Okay, so moving on to step 2. Again, we had done a couple of things. So let's just go ahead and work off this first given, which was gives us radii. Let's go ahead and say that CO is congruent to DO, radii of circle congruent. All right, and then from that we can state that BO is congruent to FO by the subtraction property, because we're subtracting these congruent BC and FD from the radii. All right, that gives us a side. Now coming off of this perpendicular given, we can state that angle ABO and angle EFO are right angles. Now remember that since we're using HL postulate, we don't need to state that they're congruent angles. We just need to state that they're right angles. So I shouldn't have said side. I've got a leg here, and these are right angles. All right. So now I have that, and that's coming from perpendicular segs form right angles from your givens. And then the last thing we need to do here is we had to draw. If you remember, we drew that. So we're going to draw segs AO and EO. 2 points, that's not number 2, that's number 5. 2 points determine a line. All right, and then we can state that they are congruent. And the reason is because they're radii. So I'm going to go ahead here for statement 6 and say same as 2. All right. So now that we've got that, those are our hypotenuse because they're across from our right angles. So we can now state that the two triangles are congruent. So triangle ABO congruent to triangle EFO by the HL postulate, and that's statements 3, 4, and 6. And then for statement 8, we can now state through CPCTC that we've got these two congruent segs, and there you go, AB congruent to EF. Okay, and there you go. Moving on, 2 more. Here we have number 19. AD is the altitude to BC. We know that altitudes form these right angles. AD also bisects BAC. So that means we've got angle bisector up here. All right, so we got these two congruent angles here. I don't know why I do that. All right, so we're supposed to prove that AD is the median to BC. Well, if you look quickly here, we can quite simply see that these two are congruent if we use the reflexive property and state that AD is congruent to itself. So altitudes give us right angles. Right angles are congruent. Altitudes, that's these, I'm sorry. Bisectors form congruent angles as well. Reflexive property, triangles congruent, CPCTC right here, then it's a median. So I'm taking a break to get that written down. Okay, so we have starting with altitudes. That's going to give us these these angles down here that are right angles. So we're going to say, I'm going to combine here and be a little lazy, that angles BDA and angle CDA are right angles. Okay. Altitudes form right angles. 3, I'm going to state that they're congruent because I am going to use side angles, angle side angle. So I am going to say that they're congruent. So angle BOA is congruent to angle COA. Right angles congruent. And we have our first angle. Moving on, we have statement 4. We're going to come off, I'll go ahead and do reflexive property. We don't have to do it, but I'm going to go ahead and say AD is congruent to itself. There's your reflexive property. And then we're going to go back to our given this bisector here and say that BD is congruent to CD. The reason coming off of here, if a seg, oops, that is incorrect, back that up, I wasn't supposed to say that. Bisecting angles, so we're talking about these angles up here. Sorry about that. Alright, so we're going to say that angle BAD is congruent to angle CAD because if seg bisects angle forms two congruent angles. Sorry about that. Alright, so that gives us angle, side, angle. So there are our 3 things. Now, we can now state that these triangles are congruent. So triangle BAD, congruent to triangle CAD, through angle, side angle, 3, 4, 5. And then we're going to use, we're trying to state that this is the median, so let's use CPCTC to, now we can say BD is congruent to CD through CPCTC. and then we can state that the median. And I'm not going to write it, but you've got it. And the reason being, if two segs are congruent, the segment that divides them is the median, or definition of median is fine as well. Okay, last one and we are done. All right, so here we have this guy here. This is letter A up here. I don't know if you can see that, but we have that triangle ABC is isosceles with AB being congruent to AC. D is the midpoint of AB. E is the midpoint of AC, and we're supposed to prove that these little guys, this down here, PBC, is isosceles. So let's see what we've got here. We've got these are congruent, and also that this is isosceles with AB being congruent to AC. So if this is the midpoint, then all four of those segs are congruent. So I think I would probably go ahead and do separation of these two angles. This would be AE, these two triangles, AEB, and let me draw the other one, ADC here. So ADC. So now I can see that AE is congruent to AD, and then AB in our givens, and AC, and then they share angle A, side angle side. These two triangles are congruent. Now if we look at that, that's going to give us congruent triangles. Let me take a second to write down our givens. Was that working the whole time? Oh my gosh, I hope that wasn't a big bank of time. If it was, I apologize. I hope you fast forwarded. I apologize for that, guys. All right, so I've got that all written down, and I was just going through my thinking process. What we're going to be doing is this situation right here is going to give us that these base angles are congruent, the whole things. Through CPCTC, we're going to say that these two guys are congruent. So these two. So we are going to be able to use subtraction of the congruent angles to state that these base triangles are congruent, which will give us the final isosceles triangle. Sorry about the mess, the weight right there. I apologize. All right, so AD is AE. We're getting that from AD is AE. And that's the division property. Midpoint. It was a double midpoint because we had double midpoint, and these are congruents. So division prop, and then let's see, that gave us a side, and then from that we also said that angle A was congruent to itself, and that gave us reflexive property there. And we already had AB is AC, which is up here, which is another side. So we had through side angle side, these two triangles were congruent. So in step 4 we could say that triangle ABE was congruent to triangle ACD. Okay, side angle side, 1, 2, 3. All right, and after that, we used our CPC to say that ABE, angle ABE, is congruent to angle ACD. And then, after that, I say then a lot, don't I? Well, I'm also going to go back and I'm going to grab this information about this isosceles triangle to get these base angles of the big isosceles triangle. So, angle ABC congruent to angle ACB, coming off of this data right here. So that's going to be if I could do if isosceles base angles congruent, or if sides then angles. And I'm just going to say if sides then angles because it's shorter. So there we have that. And then statement 7, we're going to go ahead and state that we're going to subtract this from these two. Okay, so we're going to subtract this one minus that one. Okay, so we can say angle PBC congruent to angle PCB through subtraction. Step 7 minus step 6. And then in statement 8, PBC is isosceles. Definition of isosceles triangle. If they have base angles congruent, it is isosceles. Or you could say if a triangle has at least two congruent angles, it is isosceles. And there you go, guys. Have a great day. Study.